I don't know how much you guys know about the terminal, more than I probably do, so. But I kind of intended for this to be an intro sort of thing, so I don't know where your knowledge of the terminal and how that, if you have any much knowledge at all. Okay, that's good, because that's kind of what I intended. I wanted it to be something where if somebody didn't know how to get started, we could at least get you started. Now, you said you have a Mac, right?
Yeah.
Yeah, so.
I'm borrowing my friend's computer right now because I kind of broke my own computer.
Mm-hmm.
Yeah, 'cause, yeah, I wasn't kind of like conscious, so like it's like kind of broken right now.
Yeah.
So
So, but Macs, basically, the reason I asked is because Macs run a Unix-like operating system kernel, and so Mac has a terminal program.
oh, the command prompt, right?
Yep.
Yeah, yeah, I
Yep.
know how to like do like run some commands on it.
Okay.
Yeah.
Okay. All right. So, if you want to, I always point out to students that if you don't want to mess with installing Linux on a computer, we have a Linux cluster computer here on campus that you can get an account on if you wanted to. If you want to get started with Linux without first installing it on your computer, but you just want to do some terminal things to try things out to learn, I'll tell you how to get access to it. I think the URL has changed, but it used to be asu.edu/selfsub for self-subscribe. And then that's going to redirect me to the real URL. And I guess I got to log in. And then it's going to want to call me. Okay. Anyway, did you get logged in or? A cluster, it's called the General Statistics Unix cluster.
Yeah, I found it.
Yeah. And I don't know, I'm already subscribed to all of these, but there's a way you can click a button and do
Yeah,
something.
it's active for me too.
Oh, okay, so then to get into general, you can do an SSH command. Are you using Windows right now or Linux? Windows?
Windows, yeah.
Okay, so in PowerShell, if you go to the search bar and open PowerShell, and if you're on your native Mac, then you can just open a terminal window and do this. For some reason, my text is yellow. I gotta fix that. Why is my text yellow? Anybody know? I'm using PowerShell, Brenda.
Click on screen text.
Where at?
No, click screen text.
I'm not seeing what you're saying. Screen text?
Uh,
Because if I go to settings, colors,
screen text.
yeah, it should be black. Oh, it's gray. I tried to set it to black on white. That's black. Screen background is white. Pop-up text is black. And pop-up background is white.
Oh, I think that's like PowerShell syntax highlighting thing.
Oh, okay.
So you should set your background to black.
Oh, okay.
Or
Anything
dark,
other than white.
Dark blue is
Anything
I
other
think
than
the
white.
default. Yeah.
I usually set it to blue, but somehow the colors weren't being displayed, so I changed it.
Let's try that.
There.
No,
That's all messed up.
This is white.
I want my Linux back. I want.
Never use one of those.
I know.
White. White.
There we go. That's readable enough.
What is going on?
It's still yellow.
What is wrong with PowerShell?
There we go. Okay. If you want to try this out, you can do SSH and then space and then your ASU username, your ASU right ID, and then that's and then you do at general.asu.edu. General's the name of that cluster. And then that should display a prompt for your password, which would be your ASU login password. So then when you get logged in, you should see something like that. Yep. Okay. And now that my screen text is set to blue, I can't see I can't see my command prompt in Linux now. There's supposed to be a command prompt right here, but it's blue, I believe. So let's see if we can change my colors to something else. Whatever. Okay, so I wanted to start with the directory structure because if you want to do stuff at the command line, understanding the way the files are organized is kind of crucial. So depending on what Linux distro, some of the files will be in different directories, but in general, when you create an account, when you install Linux and create an account, or on your Apple, you have a home directory where you can store all your files. I use Executable, which is an Ubuntu-based distribution, and in that distribution, your home directory will be in a subfolder, which is called. Well, let's start at the top. So at the top, the way the files are organized in the directory system, or the file system, is that they're organized into directories, essentially, which are also called folders. And at the top, you have a root directory, which is indicated by a /. And then underneath of that, we can have other subdirectories. So if you were to look at the directories which are in root, which you can do, the ls command stands for list, and that lists the files in the current directory. So if I do ls right now, when I logged into General, I'm in my home directory, so the files that I see right now are in my home directory. If I want to see the files that are in the root directory, I can do an ls and then do a /, and then ls has an option, so that option or argument tells it to display the files that are in the root directory. And you can see those files like, you'll always see user, that one will always be there, generally var. Most of these are pretty standard. Most systems are going to have a bin, a boot, a dev, etc. Home is where user directories go. Unless if you're administering the system, you don't have to mess with the system directories too much. But when you start getting into doing more system administration tasks, especially at the command line, then you might need to do that. So let's just focus on home then. So /home is where the accounts go when you add users to the system. And so on my ASU ID is kburger2. So when I log into General, My home directory is, if you do a pwd command, pwd stands for print working directory. Okay, Mike's dead. Oh, okay. You create. On general, it's going to be different because it uses the files that you put on general are accessible. Like if you have your ASU Google Mail account, you can access the files that are in general through your ASU account. So, but anyway, your home directory is where you can store the various files and things. Now, when I teach this topic in CSE 220, by the way, what's your major?
Computer science.
Okay.
I'm in 205 right now.
So you're in 205, you'll take 240 next semester, and in 240 they're supposed to teach you a little bit about Linux. And the CSE majors take 220, which is the same course, but focused more for those majors. I used to teach 220 a lot, and I have what I call my GNU Linux manual, which I was going to show you. So if you go to a browser window and go to that page, devlang.com. I used to have that hosted at a file company that got bought by GoDaddy, and I'm in the process of trying to find a new ISP, or not an ISP, but a hosting provider. So right now it just redirects to my ASU web account. But anyway, on that page, there's a document here which is called the latest revision. That's the one I wanted to open up with. And I wanted to go to chapter, let's see. Yeah. I just noticed, oh yeah, chapter 5, the Unix file system and command. Oh, by the way, I use *nix in the document because some people think Linux should be called GNU Linux, and some people think it should be called other things, and so I just use *nix for, star stands for anything, so that means any version of Nix. So that would refer to Linux or Unix or whatever Mac runs. But I wanted to go to chapter 5 because chapter 5 is where we talk about the...
Like, what is like the differentiation between like all the mixes?
Yeah, that's a good question. The original operating system, which Linux is somewhat based on, was called Unix, which came out in around 1970. And so it was called UNIX. There's a story behind that. And then, and that was marketed and sold by AT&T. And then Linux came along. Linux is actually not an operating system. It's a part of the operating system called the kernel. And the kernel is sort of the part of the operating system that does things like managing the files on your disk and dealing with network issues and scheduling processes to run and those sort of low-level things that have to happen so that your system can do what it's supposed to do.
So like you mentioned earlier about the Ubuntu, that is the operating system?
That's a distro. So Linux, we have what are called distros. Okay. And so what they'll do is they'll take the Linux kernel and then they'll package it with a lot of other required programs that you need to have a working Linux system, as well as some application programs. And there's hundreds of distros. If you're curious, one of the websites I go to check on these is called DistroWatch. It's DISTROWATCH.com, I think. There you go. And on the right, they have their little page hit ranking. So they have a list of, they've got pages on hundreds of Linux distros, and so they maintain a page hit ranking. And so their page hit ranking is supposed to be somewhat correlate to how popular that distro is right now. And Manjaro, Mint, Debian, Ubuntu, those are obviously some of the more popular distros. If you're looking to start out with something that's easy, that doesn't require a lot of system administration, you just want to get it up and running, Mint has traditionally been a pretty easy to install distro. Mint, it's number 3 on that list. What would you guys recommend? Mint. Ubuntu's a good one to start with. It's fairly easy to install and use.
There's also Prof, which is built over Ubuntu, and it's just easier to install than Ubuntu. So it's identical to Ubuntu, but just better.
Really? It's got a better installation?
There's also Elementary OS.
Oh, here's Pop OS.
The Mac-like interface. Yeah, it's made by a company called System 76.
Uh-huh.
They build Linux laptops that are open source.
Oh, okay. And Elementary, doesn't Elementary use the Enlightenment
Yeah.
desktop? Oh, no, that's Bodhi Linux. One of them uses Enlightenment, which I can't get used to. A lot of people start with Ubuntu or Mint, which is based on Ubuntu, supposed to be easier to install. Okay, so that's one of the things. If you want to get started with Linux or use Linux, you have to choose a distro. And I guess you do that based on recommendations for people or just trying things out. When I started using Linux, there weren't that many distros. There was like Debian and Red Hat and SUSE and 3 or 4 of them, and now there's hundreds of them. So you just kind of choose, but I would steer you towards Ubuntu or one of the Ubuntu-based distros. And usually it'll tell you, like if you go to a web page, like Elementary, for example, somewhere in this list of information, if it's based on another version or another distro, it'll oftentimes tell you in the documentation what distro it's actually based on. I don't see it right here. It may be on the actual web page itself, but somewhere you can find out whether this is based on an existing. Oh, here you go. It's here. So Elementary is based on Debian. Ubuntu is based on Debian or Debian. So Debian's sort of a base distro on which a lot of distros are based. What they'll do is, like Ubuntu, they take the Debian distro that the Debian people release, and then they add things to it and remove things and create their own distro. Yeah, the thing about Linux is it's open source. It's free and open source software, which free means, as Richard Stallman says, free is in free speech, not in free beer. So, but in theory, yeah, they can't really charge for it and not, conform to the license agreements. So a lot of distros, they just take an existing distro and make changes, modifications to it, and then release a new distro. Now General, when getting back to General then, when you log into General, there's a command you can use to see what distro you're using. It's LSB, I think. Nope. What's the LSB command? That must be an Ubuntu command, because it's their version. They're running Red Hat. They're running Fedora. Uname. Do uname. Uname /-a. So uname /-a. I don't know what uname does, but when you do /a, it prints out a lot of information about the version of the operating system you're running. So this says that General is running version 3.10.0 of the Linux kernel, I think, and then 64-bit version. That's the date it was built. What distro is that? Hmm? Yeah, there's no distro name here. Yeah. It used to run Fedora, I think. Oh, yeah, let's try that. That's another way. Try cat and then it's slash proc,
Yeah.
slash proc. It says Linux,
Red Hat.
it's Red Hat. Yeah, Red Hat. So cat, proc is a directory, so slash is the root directory, and proc is a directory underneath the root directory or subfolder, and then version is a subfolder or a file, I guess. Is it a file or a folder? It's a file. This is a file. So what cat does is it displays the contents of a file. So if you say cat file name, it sends the contents of the file to the screen. So this is just displaying the contents of that file. And that file contains the actual version of Linux that they're running. They're running Red Hat 4.8.5. And it was compiled using the GCC compiler suite. More information than you want to know. But that's useful from time to time because I can't even remember what version of Linux I'm running. So I have to sometimes do that command to refresh my memory. In the document, oh, before we go on, other questions?
I think I'm good for now.
Okay. Let me go through the file naming structure, the directory structure, just so you're familiar with that. Because like I said, if you want to do a lot of things at the command line, you've got to sort of have a good understanding of the directory system, file system. So I'm trying to find that chapter 5. Here we go. So this first section, I just talked about some of the common directories that you'll find in a standard sort of Linux system and the contents of those directories. Most of this isn't that relevant unless if you're going to be doing a lot of system administration utilities. If you just want a version, I don't have a lot of time to mess with system administration stuff, so I just want a distro that I can get up and running quickly, which is why I use an Ubuntu-based distro. But even if you don't want to mess with system administration stuff, oftentimes you end up still having to at time to time. So these are directories that are mainly important when you're doing that sort of stuff. And that would be a totally different workshop. Then we have, as I mentioned, home, and then your working directory where you store your files will be located somewhere under home. Now I think on Macs it's /user. Do you guys have Mac? I think on Macs they don't do /home/username. It's /user something. It's a different directory than what you would find in like an Ubuntu distro. But even on a Mac, when you open a terminal window, it's going to put you in your home directory, wherever that is. If you want to know what current directory you're in, you have this concept of current working directory. So on my general, let's just assume I'm under /home, even though I'm actually not. Since my ASU ID name is kburger2, then this is going to be my home directory. And somebody else, Pebbles, will have a home directory for her files, and everybody who's on the system has their own home directory. And then we can talk about file name paths or direct file system paths. So a path, when we're talking about the file system, is a way of specifying the location of where a file is at. So by default, in your home directory, until you create any subdirectories, you may or may not have anything in your home directory. There's going to be some files there when you install like Ubuntu. There will be some files that get installed there. But let's just assume there's not. So then we start out with nothing. There's always two files that are stored in your current directory, which are called dot and dot dot.
Oh, is dot dot? Is the dot dot like the command to like escape to like the previous directory?
Yes. Dot refers to the current directory. So dot refers to the current directory. So you have this concept of current working directory. When I log in, this is my current working directory. And if you do pwd, print working directory, it'll display your current working directory. So whatever your current working directory happens to be, there will be two These are directories, I guess. Technically, directories are stored on the Linux file system as files, so directories are just files. I'm trying to decide if these are files or directories, but it doesn't really matter. Dot refers to your current directory. Dot dot refers to the parent directory, so the one above you. Yeah. We refer to this one as the parent directory. So for example, let's make a subdirectory real quick. So to create a subdirectory or a new folder, you do mkdir, and let's just call it foo, F-O-O. Okay. And now if you do an ls command, you should see in the list of files that are displayed, here's the directory that I just created.
Question. I remember, like, I used, like, the terminal in, like, the Windows before, and then, like, I remember, like,
Yes.
the command ls, like, dir, for, like, the directory.
dir is directory in Windows is more or less like ls.
Yeah, so, like, what's the difference between ls and dir?
Oh. Oh, you mean, well, dir is the name of the program that you use in Windows to display the contents of a directory. And then ls is the name of the program you use in Linux to do the same thing. Now, you were talking about ls.
Like, I remember doing, like, ls space and then dir.
Okay. What that would do is it's going to basically look for a directory called dir in your current working directory. Because dir, in this context, the syntax for ls in this context is ls, and then you give it the name of a directory you want to display the contents of the files. So I'm not quite sure what you were doing in that environment, but what this would do is it's simply going to look for a directory called dir, and if it displays it, it'll display the contents, but since it didn't display it, it just said it couldn't find it. Yeah. I'd have to see what you were doing in that other environment to see what context you were doing that in. So we have, let's see, I don't want to get off screen. So we have CD, PWD's handy to know, CD, ls, make dir, print working directory, ls lists the contents of a directory, make dir is how we make a directory or create it. Now that we've created our directory, we can make that our current working directory. So we're still here. I've now created a directory called foo, but my current working directory is still here. If I want to make foo my current working directory now, I do a cd command. And cd is short for change directory. So
What's the difference between, like, your cd and cwd?
PWD stands,
CD and cwd.
yeah, what, CWD is not a command. Yeah, I should be more explicit. This is not a command. This is just my abbreviation for current working directory. The command to display the current working directory is actually PWD. So this is not a command, it's just my abbreviation for current working directory. So now that I do cd foo, then when you do pwd, you'll now see that foo, I have my bash prompt is set up so that it displays my current working directory. And so foo is now my current working directory because I just did a cd foo command. Now do ls dot, do ls dot dot. That'll display the contents of the directory above you, the parent directory. If you do ls dot, it'll display the contents of this directory. So ls dot is equivalent to just doing ls, and ls dot dot does the parent directory. Now, let's make another subdirectory under called foo. So do make dir, let's call this one bar, B-A-R. And then let's make bar our current working directory. So we do a cd bar command. And now do ls dot dot. And that would display the contents of the foo directory. And if you do ls dot dot / dot dot, you can chain these together. So this is my current working directory. ls dot dot displays the contents of this directory. Dot dot displays the contents of the directory above me. Oh, actually, I'm under bar. So bar dot dot sends me here, and then dot dot sends me there. When you specify a file name that starts with a dot or a dot dot, you're specifying what's called a relative path name. So the path name or the path is how you get to the file starting at the root or starting at some other directory. If you start at the root and you follow the list of directories down to get to the file that you're interested in, then you're following what's called an absolute path. And if you start here and you say, show me the contents are in this subdirectory, then you're starting, instead of root, you're starting here and going down. And when you do that, you're specifying what's called a relative path name. So if we do ls, say ls/usr, that's going to display the contents of the usr directory underneath the root directory. And since that command starts with root, that's an absolute path name. So sometimes you have to specify absolute path names to files, and other times you can get by, most of the time you can get by with just specifying a relative path name to the file. And it's called relative because where you end up when you do this relative path name, where you end up is relative to where you happen to be currently. Yeah. So sometimes we specify absolute path names, sometimes we do relative ones. So options. Command line, these various commands have options or arguments. Most of them do, many of them do. So when you specify the command, you can specify options on the command line. And what the options do is the command will have a basic function that it does. And options allow you to sort of alter the way the command works so it works slightly different. So for example, if you do ls, it just displays the contents. Well, let me go back up to a directory where I've got some files in. Oh, let me go up to, I'm currently here. Let's go back to my home directory. So if I do cd // // I'll end up back there. There we go. And now if I do an ls, it just displays the contents that way. If you do ls-l, that's an option -l. And options generally start with either a single hyphen and then there's a letter usually, or there'll be two hyphens and then there's usually a string or a word. So -l says do a long listing.
Oh, okay,
So instead of displaying just the files this way, it displays them this way, and then it shows you, these are called the permission bits on the files. And these are a sort of an old-fashioned way of making files read-only or write-only or something like that. If we have time later, we'll talk about the permission bits. But you can set a file so that it can't accidentally be deleted. If you make it read-only, then it can't be written. And then, so that's what these bits represent. These numbers, I have forgotten what those numbers represent. I don't know. Off the top of my head, I've forgotten. In Linux, Unix, you have the concept of groups. So you can belong to a group and you can belong to multiple groups. By default, in Ubuntu-based distros, when you create your user account, it's going to create a group with the same name as your user account. So on general, there's a group called kburger2, and then there's also a user kburger2. And I am in the kburger2 group, and I'm the only person, I believe, that's in the kburger2 group. If somebody else was in the kburger2 group, then in theory, they would have access to my files, if the permission bits were set up correctly. This column displays the owner, the group owner of the file. So files are weird because they can be owned by both users and groups. And a file can be owned by a group, but not be owned by the user. You may see root username. If you see root here, that would mean that like here, root is the owner of that file. And that means that I'm the owner of the file, the user owner. This is the group owner, user owner. So if I happen to be both the group owner and the user owner, I can do what I want with the file. If you're not the group owner, but you're the user owner, then depending on the settings of these permission bits, you may or may not be able to do things with the file. But that's getting a bit farther ahead than where I wanted to go tonight. But if you want to talk about that sometime, we can. And you can always stop me whenever you want to ask a question. To get help, for example, how did I know -L was the command option that I used with ls? Unix was invented in the days before the internet was widely available, before the web, and so there's an old-fashioned manual command, and if you type man, it stands for manual, and then you type the name of a command like ls, so do man space ls. That displays the manual page for the ls command. And you can read through here, and manual pages can be difficult to read because it's not always clear, but you can see a list of the options. So let's see here. Most of these I never use. Oh, here's a useful one. Scroll down to -R. If you can find /capital R. It's also the option is --recursive. Okay. Go back to your terminal window. You can just hit Q to quit. And do an ls. Go to the root directory. So do cd. Well, we don't want to do that. Well, that's okay. Go to the root directory. So do cd / and make root your current working directory. And you may see that your prompt changes. I've got mine set up so that it displays my current. Oh, by the way, in Unix systems, this tilde character in Ubuntu systems, tilde refers to your home directory. So I was in my home directory. Now my current working directory is the root directory. Now, if we do an ls now, it'll display the contents of the root directory, just like that. And if you do ls-l, it'll give you a long listing. Now, if you do an ls-R, it'll do what's called a recursive listing. And what that means is it'll list the contents of this directory, then it'll go this direction and list the contents of this directory, and it lists all the way down, and then it comes back up and it'll list all the contents of these directories and then all the contents of these, so it does basically a recursive. And yeah, and if that takes too much time, that's weird. I don't know what I just did. I've killed it. Oh, maybe it isn't.
Try pressing hold Q.
That's weird. Huh. I've killed it. That's interesting. I've never seen that happen. Control C doesn't work. Control D doesn't work. Escape doesn't work. I think I have an old cartoon of a guy sitting in front of a computer and there's like parts everywhere, like the computer exploded, and his face is all black. And he's like, I didn't expect that to happen.
Oh, connection timed out.
I don't know what I did. We may have to just start PowerShell up and start it again.
Open something and the connection timed out, apparently.
Yeah.
Now,
Try enter and then tilde dot.
Oh, other way. Tilde dot. Oh, what'd that do?
That's a weird key combo to kill an SSH connection that's hanging.
Oh, I didn't know that.
Yeah,
I
found out about it.
So enter tilde dot will kill an SSH connection. Okay. So we should be now back at the PowerShell prompt. And are you back at the PowerShell prompt? Or press enter and then hit the tilde character, shift 1. Or it's shift character next to 1.
Yeah, next to escape.
Yeah.
oh, okay.
And then dot. Did that kill your job? Okay, now you should be able to up arrow
Yeah.
and connect again. Let's try that. I think I know what happened is when we made root our current directory, and then I had you do that ls-r, I told you it was going to walk through all these subdirectories displaying all the contents of the files. It walked into a subdirectory somewhere, I think, where it was trying to open a network connection or something, and it got hung up. So we don't want to do that. Make user/user your current working directory. So do cd/USR. USR stands for user. Now try ls-r, capital R and C. There we go. And that's what it should do, because it's displaying not only the contents of the current directory, but all the directories beneath the current directory. And when you get a Linux command that's out of control like that, you can generally hit Control-C, and that will kill it. That sends a quit signal to the process and kills it. Okay, so with ls, the syntax is basically ls, name of the directory you want to display. If you want just information about the file, like let's suppose, for example, that you've got a file and you want to know when the last time was that you modified the file. Then you can do ls and then do -l, and then you can just specify the name of the file. So let's go back. I'm going to go back to my home directory. And in my home directory, there's a file called .bashrc, and there probably is in yours. So if you do ls -l .bash rc, it'll display the long. This is called, L stands for long. So ls gives you a regular listing, ls gives you a long listing. And the long listing here, this says I want to do a long listing, and so it just displays the long information. So that's a quick way. Like if I want to know when the file was last modified, I can do an ls, give it the name of the file I want to look at. .bashrc is a file that contains commands, essentially bash commands, so that when you open a terminal window, the commands in .bashrc will be executed. So if there's certain things that you want to do every time you log into Linux, then you can put those commands in your .bashrc file, and then every time you log in, those commands in .bashrc are executed before you get the little prompt that displays. And so that I have certain commands in my bashrc because there's certain things I want to do.
Is it possible that like it doesn't, that, like there's no such file?
Yes, it may not exist.
Yeah, 'cause
Did it not exist?
it says-
Okay. Yeah, try doing instead of bashrc, try using a file name that's .bash_profile. So do the same command. You can hit up arrow to retrieve the previous command, and just change that to bash_profile. That file probably exists. That one doesn't exist either. Okay. The files that start with dots are called hidden files, and when you do an ls command, hidden files don't normally show up. I'm pointing this out just because I forgot to mention it. So if I do an ls-l command, notice that all of the files, none of the files that are being displayed start with dots. If I do ls-a, these are the only two options I ever use with ls, or -a and -l. -a does all. And so do ls-al, and it'll show you not only the files that we were seeing, but it also displays what are called the hidden files. And hidden files in Unix and Linux are just files that start with a dot in the file name. It's not actually hidden from anybody. It just doesn't show up in a regular ls command. So when you do ls.l, you should see ls.a, you should see some files.
ls.a?
Sorry, ls space -a. I think I said .a, but I meant /a. Dang it, -a,
Okay.
dash.
Yeah, okay, I get it.
For some reason, your .bash profile didn't get created. That may be because they're running Red Hat instead. I don't know. I know when I install Ubuntu, it installs that .bash profile, .bash RC file for me. Okay, so let's go back to the document and see here if I've... So path names, that section on relative and absolute path names is kind of important. Section 5.3 is where I talked about commands and arguments and the options. So what I've been telling you about the various options. And in general, a lot of commands have a -- help. So if you do, for example, GCC is the C compiler that's installed on most Linux systems. So if you do GCC -- help, it'll display, it runs the GCC program and then it displays help information. And that help information may scroll off the screen so quickly that you can't read it. So there's a way of sending the output from this program so that it becomes the input to another program. Unix was designed with the philosophy that you would have these small, sort of simple programs that would do one thing, and that you could sort of chain these programs together to make them do a lot of different things. And so we can do things like take the output of one command and make it the input to another command. And the way you do that is you do a pipe operation. And the pipe operation, the vertical bar symbol, which is shift \, I call that the pipe symbol. And so like if you do, let me do this GCC -- help, and then do the vertical bar or the pipe. And then what that says is it's going to take the output from this program, and I'm going to send the output from this program to make it the input to the program that I'm going to run, which is called less. And when we do that, what all less does is it reads the input and it displays it one screen at a time. So now that I can use my page up and page down keys to navigate around. And that's handy if you've got a large document. If you don't want to mess with loading the document in your editor, you just want to look at it real quickly, that's a quick way to look at the document. That's very handy. I use that a lot. Section 6.4, I've got an example in the book here. So this is my example working directory structure. It's all sort of made up. PWD we've talked about. LS we've talked about. The hidden files we've talked about. Permission attributes. If I go back to the long listing, so if I do ls-l, I'll show you how to read these. I barely know how. If you see a D in the first column, that's a directory.
Okay.
So I have mine set up so that it colors my directories in blue. In Bash, I guess it's a Bash thing, you can create a text file that tells it what colors to display file names in. So like I have mine set up so that file names, directory names are displayed in blue. You can search for that to do that, but I'm not going to go over it. So if you see a dash, it's not a directory. And sometimes you'll see something other in that column. Sometimes you may see an S. I don't know what that means. It has something to do with something. These are the remaining ones. You'll see RWX or R-X. You'll see either R or dash, W or dash, or X or dash. And there's 3 of those. R means read, W means write, and X means execute. So the first group of 3 bits are for the group owner. So looking at this, say this backup directory, so general, they automatically back up your files and they get backed up to this subdirectory somehow. and I can't delete this directory because I don't own it. Root is the group owner, and so RWX here means that root has read, write, execute permissions. Now, when execute applies to binary executable programs. So a program that you can run will have an X bit set. When you see an X bit set on a directory, this means that the directory is not executable. When you see an X bit set, that means you can CD into the directory and display the contents of it. You can CD into a directory if the X bit is set. I'll show you where this is at in the document. The permissions Now, I thought I had more description about what the permission bits represent, but maybe not. I think I do somewhere, but I'm not sure where right now. So you'll see RWX. So in this example, FredF is the group owner of a.out, and that group owner has read, write, execute permissions. A.out, when you build a program using the GCC compiler, the default file name of your binary executable program will be the A.out. The next group of 3 bits are for the user owner. So group owner, user owner. So the group owner and the user owner both have RWX. The last group of 3 bits are for others, and that would represent the other users on the system. And in the old days, before security was really a big deal, Unix didn't come with really, sort of well-designed security. It was designed to be an open source, shareable sort of operating system rather than to be sort of closed and secure. And so the O bits, the other bits, those aren't all that relevant nowadays. Yeah, the last 3. Those aren't all that relevant nowadays. So you can change those with a command called chmod. It's chmod. I've got the command here is on page number 27. About the main thing you would commonly maybe need to do is change the file status so that it might be read-only instead of writable. So, like for example, going back to my home directory, I've got a file in my home directory called foo.py. It's a Python script. And let's look at the permission attributes for that. So I can do ls-l foo.py. And you can see that, let's see, what do we have here? The group owner is me, and I have read-write privileges to that file. The user owner is me, and the user owner can only read that file. He can't write to it. But because I'm the group owner, I can also write to it. Now, I'm not sure why I don't have W here. I'm not sure why that happened, but let's suppose I want to put W here. Okay, so there's 2 ways to do the chmod command. One way is the easy way, which seems more difficult, and the other way is supposed to be the easy way, which is actually more difficult. If you do a man command, so do man space chmod, or change mode, this is kind of a complicated program, and I can never figure out the options. I do it this way. You know binary, right? Oh, you've not studied binary and digital logic? Yeah, like bit binary notation 1s and 0s. Yeah. This is the easy way to understand these. That's right, exactly. That's right. Oh. So we have group owner, user owner, others, mostly irrelevant. Think of these as binary numbers. So there's 3 bits for this. This is bit 0, bit 1, bit 2. That means there's 8 combinations of bit patterns for those. Right? If I want this to be, it's currently that, which would be 100. So it's currently 400 in binary, 400, 100, 4 I mean in decimal. If I put a W here, that would be 110, which would be 6. So this is currently what I have over here. Whereas this is currently 644. 644. If I want to change that so that I have write permission, I can do change mode 664. So I'm going to change the W in the middle. I'm going to change that from a hyphen to a W. So this is currently 644. If I put a W there, I'll have 664. So I'm going to do a command 664 foo.py and then repeat my ls command. And you can see now there's a W there.
Okay.
So removing and adding write permission is something that I do sometimes. That's kind of common. The other thing is sometimes you have a binary. If you start writing bash scripts, you need to make the bash script file executable. So let's create a little bash script real quickly that does something. I think Nano is installed on this computer. Let's create a file. Do Nano and then space, and let's create a bash script file called script.sh. Bash scripts normally end in a .sh extension. So bash is it's a program essentially that runs, and you can give it commands and it does things, and you can write script files that tell it to do script commands automatically. So you can program bash. It's got a programming language built in. And so Nano is a real simple text editor, and so I'm just a bash script is nothing more than a file that just contains bash commands. In addition to, there's bash internal commands that you can do. So you can do things like loops and if statements and things. Let's make a bash script that now I'm trying to think of something that's not too difficult, but well, here, let's do this. I've got some examples. In my document, if we scroll to chapter 11, I've got a section on bash scripts. Nope, I'm too far. Did you find 11? You're ahead of me. It's 12. Sorry, it's chapter 12. I just found it. So I've got a chapter here that talks about writing bash shell scripts, and it's just real simple. It doesn't go into everything. But okay, so here's an example of a script. So suppose I need to do this operation quite a few times and I get tired of typing the commands manually and I want to automate it. Then this bash script, what it does is what does it do? It moves to the temp directory and then it removes all of the files that have a .o extension. So rm stands for remove. And the way you delete a file is you do an rm command. So if you say rm file name, it'll delete that file from the current directory. It always looks in the current working directory, unless if you tell it to look elsewhere, like using a relative path or an absolute path. So that doesn't do anything really all that useful, but it's just an example. So I'm going to just create this script. So mv tmp and then rm star.o. We can talk about globbing, file name globbing, maybe in more detail later, but for the time being, when you say asterisk or star dot file name extension. Star refers to every matching string. So star.o means delete any file that has any file name that ends with .o. That's what it means. So I'm going to save this in a file, do Control-O to write out, and I'm going to save this to rmo.sh. I'm using the example that's in the document here, and this is on page 62. It's the top example. Oh, this first line, by the way, there should be a just like that. Comments in bash scripts start with a # or a hash mark. So you can put comments. That first line, basically what that does is scripts can be executed by different programs, and that essentially tells that bash that this script should be executed by the bash shell. That's basically what it does. So now that I've got that, I'm going to write that file out to disk and call it rmo.sh. I think I have a file already named that. There's something going on. It's not letting me save that file. I'll call it foo.sh. Oh, okay, I see. It says it saved it. I'm not sure what file name it saved it under, though. Do I have a foo.sh? Oh, here it is. I saved it multiple times, so it saved it. I guess it saved it. Anyway, if I do an ls-l to show the long listing for that shell script, this is called a shell script file. Notice that it doesn't have X here. That means I can't run this script unless if it's marked as being an executable file. So the way you run a shell script, if it's in your current directory, so you type, if the shell script's in your current directory, you type // and then the name of the shell script file that you want to run. So for me, it would be ./rmo.sh. And it says, in this case, it's saying permission denied. So I don't have the right permission to be able to do this. And that's probably because the X bit is missing. So what we need to do is on this file, we need to put an X, probably both of those. So we need to change the permission here to be 111, which would be 774. I don't care about others because that really doesn't have any impact. So I need to change the permission. So I can do chmod 744 rmo.sh and now do my ls command, and oh, I did 744. I meant 774. 774. So 774, now I've got the X bit set. Now, if I try to run that script by doing my / script name, now see it's complaining because I typed NV instead of MV in my program. To move a file or to move to a different directory, you do MV, and I accidentally typed NV. But I've got a syntax error in my shell script is the problem. Oh, well, anyway, the point I was trying to make there was I wanted to show you that the two primary permission bits that I usually muck around with are the read-write bits and the executable bit, and that's usually when I'm dealing with shell scripts. When you just build a program using GCC, using the C compiler, it should set the X bit for you on your executable file. And if you want to, we can talk at some time about doing building using the C compiler at the command line too. How long we been going? It's been around an hour.
Yeah, we started at an hour and a half.
Yeah.
Probably more like an hour 15.
Well, we've been going a little bit over an hour, so I think I'll stop here this week. I hope you'll come back and have more questions, because I want this to be interactive, and so if you have questions, those would be excellent. But before we go tonight, do you have any questions I didn't go over that you really want to talk about?
I don't really have questions right now, just because of the fact that I'm just like not very familiar.
You don't.
Like,
If you don't know what questions to ask, then you don't have any questions, right? Yeah. Yeah.
that's probably what I'm doing.
Right. What I would recommend is if you want to get started messing around with the Linux and just learning the terminal, you can just log into General, and that'll get you to a point, where you don't need the GUI interface to do any of that with. And then at some point, if you want to get started with Linux, then what I do is I run Linux on my laptop, and I run Windows in a virtual machine for when I need Windows. You could do the opposite. For example, you could run Apple on your, Mac OS on your Apple, and you could run Linux perhaps in a virtual machine.
The problem with my MacBook is that it's just that like it just doesn't have enough space. It only has like 125
Oh,
hard drive.
so you would have to have an external hard drive. Yeah, yeah. Well, the thing is Macs essentially, I don't think they use Bash as their shell script, but it's similar, isn't it?
They used to, but they switched to Z shell when they were.
Z shell, okay. There's different shells. So Bash is what's called a shell, and it's a program that essentially the user interacts with the operating system by typing commands. And Brenda said Macs probably use a different shell than Bash, but so that means some of what I tell you may be different, but some of the commands, like CD is change directory. It doesn't matter what distro you're on. It doesn't matter what shell you're using.
Like I use like CD like when I'm like running like
Mhm.
programs or like
Yeah.
Python
Yeah.
programs, like a lot of times I am using the terminal and I'm
Yeah.
using like some commands, but they're just like the basic ones.
Right.
Just navigating through like the path.
Right.
through my, like,
And those are the basic ones you got to start with, right? Is understanding the directory system, the file system, and how to navigate around, how to create directories, delete directories, create files, delete files, change permission bits, move files, zip them up. Those are the basic things that I wanted to go over. So we talked about a half a dozen commands tonight. Yeah. There's so much I could go over. There's just really, not enough time. I just want to cover the basics.